All right, welcome back to the second part of our notes here. This is when we're going to jump feet first into isotopes. So this may be a little bit difficult, and that's okay. We're going to spend quite a bit of time on this. So if you do have questions at any time, let me know. All right, so isotopes are really interesting in that not all of the atoms of an element are identical. So this is where isotopes come in. Isotopes are atoms of the same element with different number of neutrons. That's very important to remember that distinction. So the atomic number is the same. That does not change because the number of protons never changes. But when it comes to mass number, that will be different because now our number of neutrons is different. Okay, so example would be hydrogen 1 versus hydrogen 2. Hydrogen 1 looks like this. You have 1 proton, no neutrons. And now with hydrogen 2, you have 1 proton and 1 neutron. Okay, so these isotopes are more stable when the number of protons and neutrons are the same. So isotopes can be very unstable. That's why they prefer to be they're, even protons and neutrons. That's why hydrogen 1 is more stable than hydrogen 2. The same thing comes up with like uranium. Those of you that are big World War II history buffs, that's when we used uranium and plutonium to make atom bombs. So, and kind of do a number on a country. But this is what they discovered, is that isotopes are very unstable because of the change in the number of neutrons. So let's talk about isotope notation because there's 2 ways to do so. They're not difficult. You just have to do some formatting in your notes. So the first one's not bad. It's the hyphen form. It's the name of the element with the hyphen and mass number. It's very important to make sure you have that hyphen there because this is what it looks like. This is the example I provided for you in your notes. Is potassium 40. That means that the atom of potassium with a mass number of 40. So 19 protons because the atomic number is always 19 for potassium, and 21 neutrons because 40 minus 19 is 21. The next one is the nuclear form. This is where you're going to have to do some text formatting. So you're going to have to go to that format or format text, and then this is a superscript, which means it's above, and you have to do this first. So it's the mass number as a superscript. And then you unclick it on the formatting section, and then you add the symbol. And this is what it would look like. So again, this is potassium 40. It's just written a very different way, and it's actually shorter to write. So a lot of you may prefer this nuclear form over the hyphen form. You will be tested on both, and we will be working within both. So just prepare yourself. This means that the nuclear notation can also include the atomic number below down here, but below the mass number, but this isn't essential since the identity of the element allows you to determine the atomic number. So you might see another number down here. That's how I remembered it in college, but honestly, this is the way to go. So let's go ahead and go over some isotope notation examples. So I did give you both of these. Let's go ahead and go over boron. So we have boron, and then we have 5 protons, 6 neutrons. So when you add those together, you get, you're going to write these in both the hyphen form and the nuclear form, by the way. So the hyphen form of this, for example 1, is boron 11, because 6 plus 5 is 11. And the nuclear form is 11B. So remember that 11 is a superscript, okay? So then I want you to work on sodium right here for example number 2 here. So make sure that you're doing both the hyphen form and the nuclear form. And I'll give you the answers in a second. All right, so the hyphen form of this is sodium 23, and the nuclear form looks like that. All right. Let's talk about the very last thing is average atomic mass. So that number is the like purple or pinky looking one right there. I did provide you with a picture with it circled and make sure that this phrase was the same color so you can kind of distinguish between the two. This means that it's a weighted average of all the different versions of an element. So it's a weighted average of all the isotopes. So this is why hydrogen just isn't straight up a 1 as the atomic mass, because it's the average atomic atomic mass. It's closest to the most common isotope of the element, and the most common isotope of hydrogen, for example, is hydrogen 2. So that's why 1 plus 2 is 3 divided by 2 would be 1.01. Which I just explained there. Well, it's hydrogen is in nature is hydrogen 1. Excuse me, I was wrong. Hydrogen 1 is the most common form. Okay. If you have any questions, just let me know.